Hi, everyone. My name is Erin Douglas, and I'm a climate reporter for the Boston Globe. On behalf of myself and all of my colleagues, I'd love to welcome you to the Globe Summit 2024. I truly appreciate you all for tuning in to our panel discussion today about geoengineering in the ocean. We have an excellent lineup of panelists for this discussion today, and I'm so excited to dive in, no pun intended. So first, let me introduce Adam Subhas. Adam is an associate scientist at the Woods Hole Oceanographic Institution, also known as WHOI. He is a marine chemistry and geochemistry department, and then he studies marine calcium carbonate cycle and how it interacts with other aspects of carbon cycling in the ocean. He is the principal investigator leading a project to evaluate ocean alkalinity enhancement as a potential way to remove carbon dioxide from the atmosphere. Adam, thanks so much for being here today. We appreciate it. We also have Dr. Whitley Saumweber. Whit is an oceanographer by training and is now an associate clinical professor of marine affairs at the University of Rhode Island. He is also a senior associate at the Center for Strategic International Studies at Washington, D.C., where he serves as a director of the Stevenson Ocean Security Project. He has also held appointments as President Obama's Director for Ocean and Coastal Policy in the White House Council for Environmental Quality, and as a senior advisor to two NOAA administrators and the late Senator Daniel Inouye, and as a visiting fellow with Stanford Center for Ocean Solutions. Thanks so much, Whit, for being here. We appreciate it. Lastly, we have Benjamin Day. Ben is a senior campaigner for Friends of the Earth's Climate and Energy Justice team. Ben's work focuses on preventing the U.S. from pursuing climate geoengineering. Ben has 2 decades of organizing experience, previously serving as the executive director of Healthcare Now, the National Medicaid for All Coalition. Thanks so much, Ben, for being here.
Thanks for having us.
So let's get started here. So geoengineering aims to mitigate climate change by deliberately changing the climate in some way. And the ideas range quite broadly from brightening clouds to putting aerosols into the atmosphere to block the sun to chemically altering the ocean. And then here in New England, there's a lot of interest around how the ocean's natural carbon cycle could be used for carbon sequestration. Oceans already absorb about 1/4 of human-made carbon dioxide emissions every year. So just to jump in a little broadly here, how would you all define geoengineering, and how do you see it as fitting into, or not, into our current challenge to reduce greenhouse gas emissions and mitigate climate change? And we can just go in order here if that works for you all. We'll start with Adam.
Sure, thanks, Erin, and thanks so much for hosting this panel. I'm really excited to be here. If we just take a step back, I think we can all recognize that we're in a climate crisis, and the number one thing to do to get ourselves out of this climate crisis is to reduce fossil fuel emissions and really embark on an energy transition away from fossil fuels. There's widespread agreement now that that is not enough. So if countries stopped emitting fossil fuels today, there are almost 1,000 billion tons of carbon dioxide in the atmosphere. A large chunk of that is going into the ocean. And that's already causing damage and impacts to the climate, ecosystems, to human health, right? And so even with massive emissions reductions, it's not enough to fully mitigate and prevent the effects of climate change. And so there's widespread agreement now from the IPCC and also federal agencies here in the US that are agreeing that those emissions reductions need to be supplemented with other techniques to mitigate the worst effects of climate change. And carbon dioxide removal fits into this category of sort of supplements to fossil fuel reductions, as do other forms of geoengineering.
Whit, I'm going to pass it to you.
Sure. And thank you also for inviting me here, and to everybody watching online. I think this is a really important topic and really critical that we have a public debate about it. So kudos to the Globe for doing this. I think geoengineering is, when I think of geoengineering, it's the large-scale alteration of Earth's physical or ecological systems. So obviously you're talking about reflecting more sunlight. That's a physical change. If you're talking about altering how ecosystems take up or modify carbon dioxide from the system, that's an ecological change. But in both cases, there is an active manipulation of the system to some degree. And I think it's important to recognize that there's a differentiation between that kind of active carbon uptake from what we might call in the ocean blue carbon approach, where you are increasing the productivity of marine ecosystems by restoration or in some cases conservation. Absolutely agree with Adam that there is widespread recognition that we're going to have to do more than just reducing emissions to decarbonize our global energy system. How we go about that, I think, is for some debate and is hopefully part of the conversation that we're having today.
Great. Let's go to Ben.
Yeah, so I think probably all of us share kind of a similar sense of urgency, need to address climate change, and we probably have a lot of values in common. I think where we might differ is that, especially at Friends of the Earth, I think that we feel that we know enough already about kind of the main categories of marine geoengineering to know that it's far too dangerous to pursue, and it's actually, I think, a very treacherous path for humanity to start going down. And I do think most responsible researchers who are even working on marine geoengineering would say that we're not ready, it's not safe to deploy yet. We're trying to learn more to evaluate whether we should use it. But we feel like we kind of know enough. And I think, especially for folks who haven't learned a lot about marine geoengineering techniques, it's important to understand just the incredible global scales that this would have to be deployed at in order to have any meaningful impact on climate. So we're talking about, putting iron fertilization over 20% of the ocean, using 5,500 chemical tankers 15 times a year. And even that would have kind of a fairly minimal impact on CO2, offsetting CO2 emissions. And it's similar for all the other ones. We're talking about, dumping 5 to 10 gigatons of alkaline material into the ocean, all over the ocean. That would require almost using every single commercial ship in the world. And it would still have kind of not a significant impact. And we're talking about transforming really the ocean ecology. I mean, some marine geoengineering techniques, transforming the disturbing marine ecology is not just the side effect, it's actually kind of the mechanism by which they're using to try and draw CO2 from the atmosphere. So I think we're really concerned, and we feel like this is kind of actually distracting from mitigation efforts. So yeah.
Do you feel like it's an important area to study?
Oh yeah, I mean, for sure. And I mean, I think the only reason that we feel we know enough that we shouldn't be doing it is because of research that's been done. And certainly we're very supportive of research, but even when we're talking about open ocean experiments, field work, I think even small and medium-sized experiments can have impacts on local ecology. So we are concerned about that, but we're fully supportive of modeling, lab experiments, mesocosm experiments, and safe field experiments. So.
Adam, as one of those researchers who's working on a ocean alkalinity enhancement experiment, can you talk about your perspective on the need for research in this area?
Yeah, I'm happy to speak to my perspective, but I also just want to recognize that there's actually a federal and international call for more research on marine carbon dioxide removal approaches. So the IPCC has called for this research. There's NOAA and the DOE are funding projects in this space. There's a White House Fast Track Action Committee that's actually doing interagency coordination around this topic of developing a federal research strategy. And this research is actually well aligned with the UN Ocean Decade goals for seeing effective, safe, and equitable action to address the Paris climate agreements. So there's really widespread recognition that this research is important to do, and we're at Woods Hole Oceanographic, we're not in the business of selling CO2 credits or participating in any voluntary carbon market. We're really interested to contribute transparent, rigorous, open science into seeing whether these approaches are viable or not. And we really feel like we have done a lot. There's actually decades of oceanographic experience in terms of understanding the impacts of ocean acidification, right? Which I'll mention is an effect of doing essentially large-scale geoengineering, right? The burning of fossil fuels is thousands of gigatons, right, of carbon dioxide that we have deliberately put into the atmosphere and are causing damages right now, right, to our ecosystems and our society. So, we really feel like this research is important to understand the tools in the toolkit, and to be, upfront and honest about what the impacts are, and whether they are worth, actually pursuing in terms of any large-scale deployment. Which, from my perspective, we don't have, we're not interested in the scale of this. We really want to see, like, right now, what can we do to show whether this is safe and effective.
So your experiment that you've been the principal investigator on would entail releasing a mixture of sodium hydrogen solution and fresh water into the ocean south of Martha's Vineyard sometime next summer. So can you tell us what ocean alkalinity enhancement is, like what it is that you're actually trying to accomplish, and how the experiment would work?
Yeah, so ocean alkalinity enhancement is a technique that has been proposed to contribute to carbon dioxide removal in the ocean. It's not a silver bullet, right? It really needs to supplement large-scale emissions reductions. That's the number one thing, right, that we have to do here. Ocean alkalinity enhancement is actually the natural way in which the oceans will, over geological timescales, take up and neutralize fossil fuel-based CO2. We know this from the geological record. We know this from ocean acidification studies, through decades of research into understanding Earth systems. And so the question really becomes, what does it look like, and is it safe and effective to speed up this natural process to effectively mitigate some of the worst effects of climate change? And that's what our project is aiming to address. This project has a field trials component, but we actually, it's way larger than that. So we have a whole component doing laboratory and mesocosm studies in controlled environments. We have a whole ocean modeling team. We have an engineering team that has really been dedicated to ensuring the safety of these experiments and to make sure that we're doing them to maximize the scientific results while minimizing the environmental impact. And we're also really committed to engaging with frontline communities who are really feeling the worst effects of climate change. So fishing communities, indigenous communities, and so on, and the public. I mean, that's why I think we're having this panel here today. So, yeah.
There's been a lot of interest and criticism of that particular proposal and experiment. And I'm curious, Ben, if you could speak to what are some of the risks that you are concerned with WHOI's experiment that's planned for next summer?
Yeah, I mean, specifically, so this is dumping a large amount of sodium hydroxide into the ocean. Sodium hydroxide, that's the world's most caustic chemical. I mean, if you spill it on your hands, you can get chemical burns. And I think, although it does eventually dissolve and mix with ocean water and become safe, there is this initial period where it would be very dangerous for any marine life that was in the water. So even the National Marine Fisheries Service kind of issued a consultation on this project, and they said it had the potential to kill, all life stages of fish that are in the area, including they're particularly worried about the eggs and the larvae that tend to float near the surface that could be killed by pouring on it. But beyond that, I think we just don't see how can you scale that up. I mean, how can we dump massive amounts on a global scale of sodium hydroxide, which is, I mean, it's if you need a hazmat team for the humans on board the ship, then I don't think we should be dumping it in the ocean where marine life is so vulnerable. So. Yeah.
I'd just like to get Adam to talk a little bit about what you all have done to try to mitigate some of the environmental concerns.
Yeah, thanks. Thanks for the opportunity to comment. And I'll just say that we've received a lot of input and concerns and questions on this project, and we're really happy to address them. The first thing I'll say is that we're not adding anything to ocean water that is not already very abundant. So sodium is the most abundant cation in seawater. It's the main ion in table salt, and that's actually most of what seawater is. And in terms of the hydroxide, that's essentially pure alkalinity, and there's actually a lot of alkalinity in seawater. And like I said before, we've really spent a lot of time engineering this process to return to, internationally federally accepted water quality limits within seconds, right? So this is, in terms of the spatial and the temporal impact, it's very, very limited in scale. And, the number might sound like a lot, but the ocean is very, very big. This is going to get diluted very quickly. In terms of the ecological impacts, we actually, one of the reasons why it's actually very useful to be doing these studies in these regional, well, we're in federal waters, but in this area, is there's a lot of baseline data out there about, which organisms are in the water at what times of year. In addition to the physics and the chemistry, it's very well understood here, actually. So we've spent a lot of time digging into these, at some points, 50-year-long data sets of which organisms are going to be in the water, when they're going to be there, at what times of year, where in the water column, and we're integrating all of this information into documenting the environmental impact of these alkalinity enhancement interventions. And just a point about scale, I think we've designed this project to answer very specific questions about the effectiveness and the environmental impacts of ocean alkalinity enhancement. We do not see this project as a roadmap for what large-scale ocean alkalinity enhancement might be. That's just not what this project is about. And I want to be very clear about that, because there's a lot of science still left to do to understand what are the trade-offs here between, impact, safety, effectiveness, equitability, and that's where we feel like this project is sitting, not in terms of addressing any sort of scale, but we really do feel like this research needs to get done now, because companies are selling the scale, right? They're selling it right now. And they're selling carbon credits right now for ocean alkalinity enhancement carbon credits. So the scale is there, and I think our concern, in terms of your point, Ben, is that by not letting this independent research get done, the market is going to control the narrative here, right? And that's what that's what we're concerned about, and that's why we're really motivated to get this research done.
I want to bring Whit back into the conversation and ask a little bit about, because you have some background in government, how do you think federal agencies are likely to proceed in the coming years when it comes to research on geoengineering, based off of what you've seen in your experience?
Well, I just want to pick up real quick on a point that Adam was making here about sort of the need and the drive on research, and highlight the critical difference between research and deployment, and recognize that there is, I think, a global drive to think about these kinds of issues, and there are other countries that are interested in these kinds of issues. And I do think that it is really behooves the US to be invested in better understanding the means of production that people are considering around climate mitigation and marine carbon dioxide capture. So I do really believe that we should separate out the questions around the science from questions around deployment, and recognize that it is always better that we be informed as much as we can possibly be about large-scale potential changes to our natural ecosystems and how we might be affecting them, either here in the United States or abroad. So how the government is looking at it, the Biden administration currently has an ocean climate action plan that is considers a wide range of actions covering all aspects of the economy in terms of how we might mitigate climate change. One small piece of that is to advocate for greater research in marine carbon dioxide capture. Part of that, as Adam mentioned, is this fast track committee that's supposed to be coming out very soon with a research plan, essentially, for the next 10 to 15 years, I believe is the scope. I would say that is right now probably as far as government has gone, and would say that is probably the single most important step, is for the government to become engaged in the research process, so that there is a role for philanthropy here, there is a role for private sector interests, but it is critically important that we have government-supported research to sort of really make sure that these kinds of things are being done objectively and with the guardrails that government-supported research have to have in terms of ensuring the safety and ecological, mitigating any kind of ecological harm that might come along with them. So that's step one. Then in terms of deployment, I think we really need to make sure that we have very much of a risk assessment period within that space. The Ocean Climate Action Plan looks towards developing a research plan and then towards deployment. And I think what's going on there is a recognition that if we're really thinking about marine carbon dioxide removal potentially as being a tool in the broader climate mitigation scheme, there's a long time that has to happen, or a long period of action that has to happen, related to not just the science, but also to developing regulatory regime. And so I think they're kind of scoping that out as we need to have this down in the pathway there. But I would also really encourage everybody involved to say, let's make sure that we have time in that space to evaluate the outcomes of any scientific program we sponsor.
And if I could follow up on that point about regulatory regimes, I feel like there are actually kind of regulatory regimes that are emerging in a couple of different international fora. I mean, as they're both saying, I think it is true that there is kind of a push from the federal government and some UN agencies to do more and more research on MCDR to kind of explore whether it's possible. But
MCDR being?
Sorry, marine carbon dioxide removal. I'm throwing acronyms around, but
no worries.
But I think from other, we're seeing a much more strict kind of precautionary approach and regulatory regime emerging from different international forums. So the Convention on Biological Diversity, for example, has already established a moratorium on all geoengineering activities. They do carve out an exception for small-scale research if it's conducted in a controlled setting. Now, the U.S. is not we haven't ratified the Convention on Biological Diversity, but I think we're like one of 2 countries who hasn't. So there's almost a global sort of regulatory agreement that, you know, nothing can go forward in terms of geoengineering, that large-scale manipulation of the environment, at least in the present time, aside from research. And the other thing is there's another international treaty called the London Convention and the London Protocol, which probably no one has ever heard about. But it exists to regulate ocean dumping and ocean pollution. And they have already established a prohibition on one type of marine geoengineering, which is ocean iron fertilization. Also ocean upwelling, which is another one that we haven't talked about yet. But and just about a month from now, they're talking about expanding that prohibition to include basically all marine geoengineering. So I think there are these regulatory regimes that are emerging, and they're mostly embracing the precautionary principle that we can't really move ahead with any of this, given the risks that have been assessed already. So yeah, I think there is regulation, not so much at the federal level in the US, but at the international level, emerging.
We have just a few more minutes left, but I'm gonna try to get one more question in and then ask a question from the audience. But in the next like 5 to 10 years, like how do you all think that this space of marine carbon dioxide removal will have changed? You know, do you think that the research will have advanced, you know, further, and in what ways? Do you think there will be more regulations in place? If you could, each of you tell me very quickly how you think this space is headed.
Yeah, well, if I can just touch and kind of segue from this regulatory conversation, because you know, we are actively involved with regulators in this space in terms of the permit application, both with the Environmental Protection Agency and then through that permitting process also with the National Oceanic and Atmospheric Administration, Endangered Species Act, and Essential Fish Habitat branches. And you know, there's with these early projects, certainly there's a lot of regulatory scrutiny on our projects, certainly in any of these really new projects that are being proposed, right? And I think that's really important, right? Because these regulatory branches really need to see what scientists are proposing and how that might feed into, and how the results of those experiments might feed into appropriate regulations for, you know, further research and eventually, you know, if it's deemed viable, deployment. So there's a lot of interest. I think the coalition that has been formed here is really scientists and then also this sort of, you know, voluntary carbon market startups. I would love to see more community engagement and federal and regulatory input into these early stages. And I'm hopeful that in the next 5 to 10 years, we can start, you know, making some decisions about which techniques look promising and which don't. Yeah. From all these different perspectives.
Great, we've got 5 minutes. Any final thoughts?
Yeah, I worry a little bit about the trajectory we are on with regard to carbon emissions and how we are not bending that curve down fast enough. And what's going to happen as a result of that is that there's going to be increased pressure for radical action. And that is, of course, both in terms of carbon mitigation and removal of carbon from our emission streams, but also potentially on these kinds of things we're talking about geoengineering. And I worry that without enough information, without enough solid ground to stand on, it'll be harder to push back on those that pressure for radical action in terms of carbon dioxide removal. And so that's something to just be aware of and recognize that pressure for action, both from the business side and from the carbon mitigation side, is going to increase over the coming years.
Yeah, I definitely agree with that. And I think looking at the big picture, it feels to me, I think we have a big problem with carbon dioxide removal in general, the role it's playing in kind of the global discussion about addressing climate change. The IPCC has been mentioned a few times. This is the agency that kind of models out different scenarios for how we could address climate change. And most IPCC models now are sort of anticipating that we will somehow in the future be able to do massive amounts of carbon dioxide removal, even though there's no CDR method that has been proven that can be safe and effective. The IPCC has mostly looked at land-based carbon dioxide removal. So at least as of the last report they did, there was no discussion of marine CDR yet. But I think reality is starting to kind of set in on the limits of land-based carbon dioxide removal. That could be a whole nother topic. But I think that's also why folks are looking more at marine carbon dioxide removal. And I think it is a big problem just because these economic models that are not really based on a feasible assessment of whether these technologies are likely to be ready or whether there's any evidence that they will, I think it's dramatically distorting countries' views of how quickly and how rapidly we have to phase out fossil fuels and greenhouse gas emissions. Because the more CDR you project into the future, the more time you have to roll back, to transition rapidly to renewable energy and to transform land and agriculture use. So I think there is a problem in general, not just with marine CDR, but with all kind of carbon dioxide removal dialogue, that it is distorting our view of how urgent the situation is and how desperate it is, with this kind of, I don't know, utopian hope that 50 years from now, our technology will be far more advanced and somehow safer than it is now.
I think I have time to sneak in one audience question that I'm going to pass to Adam, just because I think it's a good one. And this person is asking, before you run large-scale experiments, I understand yours is more of a smaller scale, but before you run an experiment in the ocean, essentially, they're asking, can modeling tell you some or most of what you want to know? Like, they're asking essentially, why do you want to go into the ocean?
Yeah, so we do have, as part of our research program, an ocean modeling team, and those models are really critical to understanding the ocean physics, the ocean chemistry, to some extent the ocean biology of what's happening. But the ocean is a very complicated place, and ocean models are a tool, but they have their limitations and they have their place in ocean science research. We absolutely need more ocean monitoring in general, right? To just understand how ocean health is being affected even right now with climate change. And it's really through observations, experimentation, and modeling that we can bring all of these forms of research together to really make progress on these really hard and messy ocean climate related problems. And that's exactly what we're doing with this research program. But we do think that, with the decades of oceanographic experience that we have and the community has built, that we're at the time where we do think we can go and perform controlled and very highly monitored experiments in the ocean where we can understand really everything that's going on.
Okay, well, I'm so sorry to say we're running really close on time here, but a huge thank you to all of our panelists today for coming down. We really appreciate it. We appreciate your expertise and all the insight that you had to offer to the panel today. And we really appreciate our audience members for joining us and tuning in to the Globe Summit of 2024. So thanks so much, everyone.